Thanks, Howard. So I just want to confirm you can see my screen.
Yes, we can.
Lekker. How's it, everyone? Thanks for inviting me. It's been a while since I've given a talk to data people, so I'm quite excited about it. And to combine paragliding and data, it's two of my favorite topics. So I've entitled the presentation for today, "Where are we flying this weekend?" This is essentially the question that I'm tried to answer with a tool that I've built. And yeah, we're going to go through it. So I'm sure everybody recognizes the picture on the screen. This is a paragliding pilot that is flying past the cable station in front of Table Mountain.
Nice.
Okay, so just before I get into the answering the data question, I'd like to talk just a little bit about what paragliding is, because there is a fair bit of misconceptions on paragliding. It is not jumping from a plane, and neither is it jumping from a mountain. Paragliding is a recognized official legal form of aviation. We fall under the Civil Aviation Association, and our craft are defined as foot-launched aircraft. If you were to cut a paraglider, take a cross section of it, you'll be looking. Tell me, can you see my mouse as I'm moving it on the screen?
Sorry, yeah. Ria. Yes, we can. I was on mute. Sorry about that. Yes, all good. Okay. We can see your mouse.
Okay, cool. Thanks. So if you were to take a cross section of a paragliding wing, you'll see that it's pretty much the same as any aircraft wing. It's an aerofoil shape, and therefore it flies when it has airflow over it. A paraglider is descending at about 1 meter per second. So if you think about that, if you were to jump off a 10-meter high wall, it'll take you 10 seconds to reach the ground, which is quite a long time. At the same time, in completely still air, you have a glide ratio of around about 1 to 7 to 1 in 10. And what that means, for every meter you descend, you will be moving forward horizontally 7 to 10 meters. So take off at Table Mountain at 1,000 meters, and you will glide 7 to 10 kilometers, so out to Milnerton, somewhere that side. We also have an airspeed range of round about the low 20s, around about 20 kilometers to 50, 60 kilometers per hour, depending on the performance of your paraglider. But these are, we can control this. We can speed it up and slow it down. And this speed will also dictate the conditions that we fly in. And then just a little bit on the material strength. I wanted to address this because most people's concerns is, oh, what if this craft falls out of the sky and it breaks? And that pretty much never happens. We fly equipment that is airworthy. It's inspected. And the braking strain on a single line, like around about a 2.5 millimeter line, will have a braking strain of about 300 to 400 kgs. So these are well-designed craft. They're designed and tested according to European norm standards. We've come a long way since the early pioneering days of the 80s and 90s, and it's a full-on form of aviation, and very accessible to us all. To give you a kind of an idea on how we fly, because most people think, oh, we soar up and down hills, and that's one form of flight. But actually, paragliding, using this craft to go places, this is why I started paragliding, because the idea of going places really appeals to me. And I'm on the screen. I've got a screenshot of a flight that I did some time back, taken off on a little hill over here called Korenberg. This is on the way to Piketberg, for those of you who know the Western Cape. And then you'll see throughout this flight, and if you look at the bottom of the screen, that's the altitude over the time of the flight. And you'll see that there's gains in altitude, and then there's drops, and there's gains, and there's drops, and so on. And that's kind of the game that we're playing. It's kind of like playing a strategy game in the sky, where when you get things wrong, the result should be that you just have a safe landing. So we go looking for pockets of rising air. This is what we call thermals. Essentially, it's a bubble of air that heats up next to the ground because the ground gets hot from the sunshine, and then this bubble floats up into the sky. And if you find the bubble and stay with the bubble, which can be 50 meters wide, it could be a couple 100 meters wide, you can use this bubble to gain altitude and go up without an engine. And probably the most common example of this is when you see birds flying and they're flying in circles. By flying in circles and not flapping their wings, they're staying inside a bubble of air that's rising up. And this is a very efficient, pure way of flying. And that's exactly what we do. Just last month, the world record was shattered. We've had 600 kilometers broken for the first time. It was done out in Texas. And just some stats on the flight over here. You can see this guy flew for just under 11 hours, 615 kilometers. His maximum climb rate was 9.3 meters per second. So he would have had various climb rates throughout this flight, but the maximum that he experienced was 9.3 meters per second. And if you think about that, us going down in non-rising air, in still air at 1 meters per second, it shows that there's a lot of air movement up and down, and we just need to, what we do is we harness it to our favor. A little bit on the takeoff. We don't throw ourselves off mountains. We don't jump off mountains. We don't hope that things work. The takeoff with a paragliding aircraft is to pull up the glider, have control, and when it's up above your head, it's inflated. That gives it shape. This is what builds the aerofoil shape. And you will be launching or taking off into wind. So you'll have wind blowing up the slope into your face. Then by taking a few steps, you might need to run depending on how strong the wind is. But by increasing your forward speed, you're increasing the airflow over the wing, and that increases the lift component. And shortly thereafter, if the ground is sloping away, you will become airborne. Now, given that we are using natural air currents to go flying, we want to fly in conditions that are safe, and this is where the weather forecasting is going to come into it. Now, speeds of less than 10 kilometers, this is wind speeds. Wind speeds of less than 10 kilometers an hour would be considered light. 10 to 20 would be moderate and roundabout ideal. 20 to 30 Ks is still okay, but more than 30 kilometers an hour is getting really strong. And this is not typically the conditions where the majority of paragliding pilots are going to fly in. So wind speeds, pretty much less than 30 kilometers is good for us, and we can also break that up further. We need the wind direction to be blowing up our takeoff slope. So if you look at the picture over here, we've got a pilot who's controlling his glider. You can see the ground is sloping away from him in front of him, and therefore in this scenario you'd want to take off with a wind that's blowing straight up the slope. So when it comes to deciding where you're going to fly, we're looking at, okay, what's the wind speed, what's the wind direction, and then choosing a takeoff site or slope that is suitable for that wind speed and direction. There's, of course, other weather variables that will impact on whether you decide to go flying. If it's raining, it would be a really bad idea because your glider is made up out of fabric, and the fabric will get wet, and therefore, it could also fill up with water inside it, and that would be giving you undesirable behaviors. And so we're pretty much looking for no rain, decent visibility. We need to see where we're flying, and sunshine, because the sun warms up the ground to create those magical bubbles of lift that we call thermals. Okay, let's talk a little bit about the weather forecasting process. It does and can get quite in depth. So pretty much what you do, and this is what I teach my students, is that you will start off looking at the surface winds and the overall weather. And so we're talking surface winds, the wind that's next to the surface on the ground, And the reason for that is every flight will always end up back on the ground, and you always want to fly in conditions where you can land safely, take off safely, and land safely. If the surface winds are acceptable, so they're less than 30 kilometers an hour, wherever it is, then that's the first box that's ticked, and now we can go through to the second step. The second step would be evaluating the wind speed and direction with various altitudes. So even though you might be taking off at, say, 300 meters above sea level on a little hill, it is quite likely that you could climb up to 1,000 or even 2,000 or 3,000 meters in the peak of summer. And you want to ensure that if you are flying, wherever it is you're flying, that, well, does the wind speed above ground level, is it still acceptable for you, for your skill level and happiness level? So that's the second box, is the wind speed with altitude good? Okay, fine, that's the second box ticked. Then we could also go more in depth where we're analyzing the temperature profile, so the air temperature profile as you go up above ground level. And the reason why we would look at this is because it is this air temperature profile that dictates the thermal behavior, how high those bubbles of rising air will rise to, how strong they'll be, and so on. So that's the next step that we'll look at. You can also look at pressure and so on. I'm not going to talk about that now. But for these various factors that you are looking at, it's not just looking at it at a specific point in time. You want to look at it throughout the day. Your flight could be 5 minutes, it could be 5 hours. But also, because we're basing our decisions on weather forecasting, which is essentially a prediction model, the models could be right and they could be wrong. And so the strong winds that were forecasted for 7 o'clock this evening may come a little bit earlier, and maybe they come at 4 o'clock in the afternoon while you're still flying. So we analyze the whole picture and then make a decision on where, when, and if you are going to fly.
Can I ask a question on that previous slide?
Yes.
So if we talk about this guy that flew over 600 kilometers, are you analyzing the data? Did he analyze the data from Amarillo right to the endpoint? So you almost know across exactly where you want to land up. So it's not, sometimes I think the hot air balloons, they sort of go where the wind takes them, or they just, the car follows them. So you're pretty sure of that entire flight path that you're going to take, and you'd analyze the whole way? Or, I mean, you're not going to be doing a radius of 600 kilometers. You pretty much know where you're going to be going to.
You have a plan, and for sure, this guy was after the world record, so definitely he would have had a plan on this. And you would forecast for the whole route. Right. And essentially, in this example over here, his flight plan would have been to take off and go downwind using the wind to his advantage, because if you're flying with an airspeed of, let's call it 35 kilometers an hour, and you have a 30-kilometer wind at your back, now you're doing 65 k's an hour. Right. So he would have planned this all the way up until landing. I'm very, very sure of it. Just on that, there was the first person to break 500 kilometers. This was done in 2008 by a pilot named Neville Hewlett from South Africa, from the Garden route. And he took off in the Northern Cape in Dar and flew to Lesotho. And how he got to doing this flight was a month or two back, or however long before that, some other foreign pilots came up with the plan, and they tried it but weren't successful in breaking 500 Ks. And he went to a meteorologist and said, I want this weather forecast that they used. This is the weather forecast that I want. And when that the conditions were predicted to happen, the meteorologist phoned him. He went out there and set a new world record.
Wow. So how much data are we talking about in terms of, if we're talking about 600, I mean, the variations across that path are quite, I mean, there's a lot of ground that needs to be covered in terms of this whole path.
Sure. So on that, you're not going to you'll be analyzing and looking at the bigger picture throughout this route.
Right.
What are the general wind speeds? How high are the thermal tops? Is there any other dangerous factors, like is there going to be some storm development or anything
Right.
like that? So that's the kind of level that you'll be planning it to, and then pretty much using your skills and
Okay.
experience in there. Yeah, and again, the forecast could be right and could be wrong, and you could change your plan, which is normally in recreational flying. We're not going to be like, oh, we're dead set on going to this point. If I encounter a headwind or a crosswind, and it makes more sense for me to change my route and go fly somewhere else, then perhaps I'll do that.
Okay. Okay, so it's not that fixed in terms of, if you find a thermal or a wind going in a different direction, you can probably take it, which may be very different to what your plan was or your end destination.
Yeah, yeah. So one of the adventurous things about this is that we don't 100% know where we're going to land.
Okay.
That's part of so there's no certainty in this, and therefore you plan a route that is acceptable to whatever it is you want to do. So if I'm taking off from Paul and flying north to Porterville, I know the places where I can land close to a road, or if not, where I'll hike out from, and so on. And so you
Right.
plan this in your planning. Yeah.
Because Piketberg is quite hectic. I mean, we've got some friends there that live right on top of the mountain.
Yeah.
There's sort of one road all the way up, and it's a long way.
Yeah.
And if you go in some other direction, it could be quite interesting. Or if you have to land in that area.
Yeah, so that's a whole little, we can, how you get back to where you've taken off from can be an adventure on its own, or you could, typically what we do out here for recreational flying is 3 or 4 pilots will get together, they'll pay somebody else to drive the vehicle, and then they'll go flying and get picked up as they land.
Okay, okay.
Yeah.
But you'd pretty much stay together, so you'd sort of want to have similar type of skills so that one person doesn't go completely opposite direction to the others.
So preferably that doesn't happen, but sometimes it does. But typically what we want to do is at least fly the same direction. So let's say we're taking off from Piketberg and flying to Porterville across the valley, that everybody in the team is flying in the same direction. So if somebody flies 20 Ks and the other guy flies 50 Ks, it's all in the same direction instead of all over the place, because then it can be a long day out.
Alrighty, thank you.
Okay, cool. Yeah, if there's questions at any time, please feel free to stop me. I enjoyed the conversation. So what I have up on the screen over here is quite this is one forecast. It's a paid forecast that I use called SkySight, and there's a lot of information just in this picture. So I'm looking at a weather forecast for a particular point. It's actually a point that I've put here in the middle of the Tutoitskloof Mountains. And on the y-axis of this chart, we've got altitude above sea level in meters. So it's 1,000, 2,000, 3,000 meters going up. And on the x-axis, we've got a time scale, which is the time of day. Then quite prominent are these barbs or feathers. That's telling me the wind speed and wind direction at various altitudes. So I can see close down around about 1,000 meters, it's southwest. It's got a single barb, meaning that's 10 knots. 2 barbs will be 20 knots. And then it's getting more and more. And up at 5,000 meters, the wind is humping. But we're not going to get to 5,000 meters. So just on this snapshot over here, I can very quickly evaluate the wind speed and direction throughout the day for this particular point. There's one other thing here. There's some color. There's a color scale, and that's what's depicted on the right-hand side of the picture, which is showing me my lapse rate, which is a change in temperature per 1,000 feet. So it's a change in temperature over a given altitude. And essentially, this purple area at the bottom has a nice that's about a -3 to -3.5 meters degrees per 1,000 foot change in temperature. So as you go up with altitude, the temperature is dropping very quickly, and that helps your bubble of warm air, the thermal, to rise because it's warmer than this colder air. But then you can see the temperature profile does change as you go higher up, and therefore your thermal will stop roundabout, just roundabout where that purple area ends. So in a snapshot here, I can look at what are the wind speeds, the wind directions throughout the day, as well as how high I can expect to go with these bubbles of rising air. Now, the unfortunate thing is that this is just for one point. So if I needed to evaluate all of the flying sites of the Western Cape, then I need to go and do this for every single one of them. And here comes the challenge. There's about 50 takeoff sites in the Cape Town region, and I'm just talking about where we're looking over here on the screen. So just our side of Cape Town, going up to Porterville, Langebaan, and Hermanus in the southeast. The weather varies significantly all over the place, and I've highlighted a few surface wind directions here to point this out. So this one on the left-hand side, which is just outside Table Bay, is a westerly. So we've got a southwester that's going to be blowing at Signal Hill and Lions Head. On the other side of Table Mountain in the southern suburbs, we've got a southeaster. In Paarl, we've got a southwester. In Worcester, we've got a southeaster. There's a northerly out here on the ocean. So things vary across the region. And pretty much, for most recreational pilots in the Western Cape who live in Cape Town, we're more than happy to drive an hour and a half to Porterville or Piketberg because it really is world-class flying. And when I say that, every summer we have foreign pilots who come and fly here because it is that good. So this entire region is what we consider, where we would go and fly, and therefore we analyze or pick sites in this region that we're going to fly at. Now, another challenge is there are multiple forecasts. I think everyone in this audience will appreciate that we have various models. So they're different prediction models. The one that I was looking at earlier on was a model. It's done by a private company. GFS, the Global Forecasting System, is done by the North Americans. ECM, the European Center for Meteorological Weather Forecast, is done by the Europeans. Meteor Blue is done by the University of Basel. So there are these different models out there, and sometimes they agree, sometimes they don't. And pretty much, you're looking at the various models, because if you're going to drive an hour and a half out to Piketberg to go flying, you want to make sure that you're going there and there's a very, very good chance that it's going to deliver the flying that you are looking for. And that's even more so when you're an instructor taking students out who are paying you for this. So you really do your best to to get the weather forecast right. The other challenge now, and this is why I built my tool, it's really aimed at the recreational pilots who don't have the time to go and analyze 50 takeoff sites. I mean, if it took you 1 minute per site to analyze, it's going to take you 50 minutes to do all of them. So that's an hour a day. And if the average pilot does have a job like Drew does. And so, to spend hours doing weather forecasting is a bit much. And so what happens is mostly people will look at the sites that they are familiar with, the ones that they do most of their flying, and because of that, they neglect the other possibilities and don't fly as much. Yeah, so and I thought that this is what I was talking about. So people focus on the options for pilots is that they may focus on the sites that they know. They might go where other people are flying. So there's a few WhatsApp groups where people share their plans, hopefully, and those who don't do their weather forecasting will try and latch on to others who have made a decision. Maybe they'll take a wild guess and hope that it works. So they'll drive up to Lions Head and see that either it's flyable or if it's not flyable. And there are some other existing solutions. Just by the way, the picture that you're looking at over here is a pilot flying out over the ridge at Hermans. So let's talk a little bit about the existing solutions. There's websites like windy.com, and they have their own apps and so on, where you can set up alerts or notifications. Like here, you can see these are email alerts that you can set up for your various sites. And then if the forecast was within that alert, that the setting that you set up, you would get an email or a notification on your phone saying, oh, look, Wednesday, this coming Wednesday at Langebaan is looking like a good day for flying. Now, there's some negatives on this, and if you just look at our Western Cape scenario over here, you're going to set up 50 alerts. It's going to clog up your email. You're probably going to lose it in your sea of email. And then with this kind of alert level that they're giving you, you're looking at one site at a time. And then as well, there's also limited variables being analyzed. So in this particular one, it's just the wind, because you can see they're saying Wednesday is looking actually like a great day for flying, but I'm also seeing that there's rain forecasted, so that's not going to work for flying. There's another solution. This one here is from a site and app called Paragliding Map. And the way they display their results of their weather forecast analysis is to put smiley faces on all the takeoff sites. If it's a smiley face, it's a yes. And then you know that's a flyable destination. However, the problem with this is that you're looking at one specific time period. So on the free version, it'll be for now. You can upgrade to the paid version, and it will tell you, okay, at 11 o'clock tomorrow, you can look at the various sites, and then you can look at it for 2 o'clock and 5 o'clock and so on. But essentially, you are looking at one time period at a time. And coming from a data background, this was very frustrating for me. So the nice thing about this is it's simple and user-friendly with the smiley faces, but I didn't find it useful in my world because of the inability to look at more than one time period. So here's what I wanted. I wanted to analyze all of the takeoff sites over multiple time periods, meaning for the next few days, and look at it in one snapshot to get a high-level idea of what's going on. So that is what I wanted to solve, and we're going to go into that now. The picture up on the screen is a couple of pilots. They're soaring. This is dune soaring outside Langebaan, just north of Cape Town. Now, what requirements do we need to solve this problem? Well, we need the site metadata, so the takeoff site, so we need to know where it is. Where it is would be a latitude and longitude. We'd also need to know what direction winds is acceptable for this takeoff site. So if we're flying off Paul Rock, then we need easterlies. If we're flying off Franschhoek Mountain, then we need westerlies. So each site will, by definition of where we're taking off and which direction the slope faces, will dictate what direction wind will be applicable at that site. Then we need an algorithm to evaluate the forecast. That's going to look at, okay, we're going to get, well, firstly, sorry, take a step back there. I spoke about the site metadata. The second thing that we need is now we need the weather forecast data for any geographic point. So if I have the latitude and longitude of my site, can I get the weather forecast data for this particular latitude and longitude? The third requirement was an algorithm to do the evaluation, to evaluate the site based on its metadata and the weather forecast. And then naturally you want this to run automatically because I'm not going to go and click run every time. And it should be low cost because I'm doing this for free. So it needs to be low cost. And then lastly, the output needed to be something that was accessible to myself and to my target market, which is the recreational pilots and the students in my school. So those are my requirements for the solution. And then just what's going on the screen over here. This is myself and a friend. I've taken the picture, and we're flying out in the Drakensberg earlier this year. Okay, let's talk about these requirements. Go into them a little bit. In terms of the site metadata, where is it? Latitude and longitude. Direction, does it face north, south, southeast, and so on. Now, where would I get this data from? So I had a few options. I could scrape websites, existing websites, for example, paragliding map that we went through just now with those smiley faces. I could scrape the South African Civil Aviation Association data because they have all the official registered launch sites in a table in a PDF. There's other sources of. There was a particular book that I had in PDF version, which I then converted to text, wrote an R script and scraped it, and then made some manual changes where I thought, for example, a certain site could take more of a southwester, not necessarily just like a wester, not just a westerly. And so I put my own knowledge into the data that I scraped from text. So essentially now what I have after doing my scraping exercise is I've got the site name, I've got the site grade. We grade our sites. We pretty much have two gradings, basic and sport, and this corresponds to your licenses that you get in paragliding. So when you're done with your student training and you apply from your first license from the South African Civil Aviation Association, you get a pilot's license, and it's called a basic rated pilot's license. Then you get some more experience, you do some more requirements and so on, and then you can apply for your advanced license, which is called a sport license. This means that you have more skills, experience, and therefore when we have challenging sites, for example, Table Mountain is a sport license site. So if a site is more demanding, then we grade it accordingly, and this helps people decide what's within their skill level. So we've got the site grading, which is helpful for people to decide where they're going to fly. We've got the wind direction. So example over here, Baines Kloof takes a light westerly to a southwest. Betty's Bay is a south-southwest to a southeast, and so on. We've got the latitude and longitudes, which is done by scraping. And then essentially what I did here was using this column over here, the directions that are acceptable, did a very crude way of saying, okay, each of these, so this particular site where we got south to southwest for Agulhas, you can see the column headings over here is various directions, and south, southwest, southwest would be a yes for it. And for each of the sites, I put a minimum wind speed of 3 kilometers an hour and a maximum of 30. So I didn't want zero wind. I wanted it to be at least some wind. Which is helpful, but not too strong. So now at a site level, at a takeoff site level, we know okay, what's acceptable for each of these sites. And now to do the forecast for each of these sites is pretty simple. All we got to do is fetch the weather data. Thankfully, there's a group of IT people and data scientists who have addressed this problem and created, if you look at there's a website called openweathermap.org, and it's specifically for for these kind of solutions, data problems. And their free version allows you a 5-day weather forecast. It does limit you on how many calls you can do per minute, but for me, looking at 50 sites, it was enough. My plan in the future is to upgrade this for the whole country, but then too I'll do it cleverly and split the workload so that I'll stay on the free version. But if you were doing this for work purposes, then it could well be likely that you would go onto the paid version and get more data immediately. Yeah, so open weather, the open weather map, using their API, I can do a call for any latitude and longitude pretty much on the planet, and get the next 5 days weather forecast. So here we're looking at the output that you would be getting, and here you can see the latitude and the longitude, and here's a particular time period. So we've got this is for the 19th of July from 9 a.m. to 12 a.m. Here's the weather forecast. So it's looking like light rain, wind direction 215 degrees or southwest, and so on. So this is the variables that I'm going to use in my decision making, in my algorithm, to decide, is this flyable, yes or no, and do it for all of the time periods over the next 5 days.
Sorry, Ria.
Yeah.
So that the previous slide to this, that's almost your one before. Sorry, that's your master data in terms of all of the sites, and that FASG wind recommendation, I'm assuming that's yours in terms of. So this remains pretty static. You're saying from experience, the best direction is south-southwest for Gulf.
100%.
Okay, and then so this is all standard, and then you do a lookup using the lat long to pick up the forecasting for that specific area.
Exactly.
Okay, thank you.
Okay, so we've been through this. This would be our fetching the weather data for the specific geographical point, and then getting that, running it through some of my own logic, and pretty much I took all of those weather conditions and I decided, is it flyable, yes or no? If it's flyable, it'll be a 1. If it's not flyable, it'll be a 0. So things like thunderstorm, drizzle, rain, and so on, snow is all going to be 0s, and sunshine, partly cloudy, etc. would be 1s. It would be flyable. Then at every site level, you would be doing your evaluation. So this is for Franschhoek, and here's our various time periods going down the roads, down the rows. We've got the wind direction here in this column over here, so we know what the wind direction is. We have the overall weather description: is it overcast, light rain, etc. And from that, determining the overall weather flyability. The wind speed in kilometers an hour, that's coming straight through from our API call, and then evaluating it. And so, and this is quite crude. In my next version, where I'm going to be doing a lot more number crunching and more a more sophisticated algorithm, then I'll most likely do the entire thing in R and not doing crude lookups. But it's definitely work to get a quick answer, and the quick answer works. So essentially, what we're looking at over here, we can see that we've got a yes, we've got a 1 over here because it's overcast. The other ones, we can see that there's light rain. The direction was acceptable because 260 degrees would fall within our range here for the west to northwest for Franschhoek. The wind speed 7 kilometers an hour is fantastic. So this would be a yes. It's a positive for this particular site for that time period. My other requirement was that this needed to run automatically and be low cost. So when I initially mocked this up,
Ria, if you go back there, that's cutting it pretty fine. I suppose you've really just got one period that you can fly, and then so that's, it just seems like you got the one period. Is that correct, with marked green? That
for this particular day, yes, and that's because rain is on the way.
Right.
Yeah. So it
would be dangerous going to Franschhoek and then you miss it or it changes or.
Yeah. So if I saw a forecast like this, then 9 o'clock in the morning till 12, maybe if I lived in Franschhoek and it was just a quick drive up.
Right. Okay. All right.
Yeah. So I pulled this morning, and it's because of the upcoming rain for the next couple of days that there's lots of zeros all over the place.
Okay. All right. Thanks.
So my other requirements was run automatically and low cost. And when I initially built this tool, I did it in Google Sheets because it was easy for me to just mock it up there to test out how things would work. And then by the time I got to it, it did work. And you can automate the scheduling of your scripts and so on. And so that ticked the box of automation, and I've got it running on Google Sheets with automated triggers. And so it's all in the cloud, and it doesn't cost me a cent. So I am using Google Sheets for this present version, but I'll most likely change it to something a bit more robust in future. As well as in future, I'd like to store the actual forecast data, which right now it's just making a decision, printing out a PDF or showing a result on the screen, but there's no storage that's taking place other than the yes or no decision. And that's things that I'd like to track in future, and do more fun things with other people's overlaying of flights and so on. So in terms of an accessible output, what I have done is I've put the output on my website to also help drive traffic over there. And I've got my school group. We don't use WhatsApp, we use Telegram. And the reason why I'm using Telegram is because there's more automation allowed. And essentially what I have going on right now is at various times of the day, the Google script is scheduled to run. It runs, creates a PDF, sends it to an Gmail email account of mine. That email account is being monitored by a bot. The bot picks up a new email, takes out the attachment, which is a PDF, and then sends it to my school group every day at 5:06 in the evening, showing them the same results, the results of this analysis for the next 5 days, so that the people in my school can have a heads up on what's coming. This is pretty much what you're looking at in terms of an output. And in terms of how my brain works, to have a table was a very useful format because it allowed me to look at the time scale, as you can see across the columns. So I can see Saturday, Sunday, Monday, Tuesday, Wednesday. I've got my sites going down the rows. I also have them split by the grading. So the first column is the license grading. Is it a basic license site? Is it a sport license site? And I've also put in some useful links, like I've got the Google Maps links and Windy links. And this means that if somebody clicks on one of these links, they can either go straight into Google Maps to help them with navigating to the site, and I do appreciate that I'm looking at one forecast model here, and I want to encourage everyone that you can't just rely on one model. Look at multiple models, look at the 2D analysis, look at the temperature, etc. Because the more prepared you are, the better your decisions that you will make, and quite likely the better the flying experience that you will have. So as part of it, there's also links that if you click on the link, it'll open up windy.com at the specific location. Then you can analyze it for different weather forecast models and so on. But you can see now to do a 50-site analysis for the next 5 days, I can see what's flyable, what's not flyable. And here where we're seeing Tuesday and Wednesday with pretty much all no's is the weather that's coming tomorrow and the next couple of days, which is going to be a lot of rain. And this was actually from a forecast that was done on Friday night last week. So we saw there were options for Saturday and Sunday. And when I built this, one of the it was a nice exercise for me to do some data and paragliding stuff together. But actually, in my own world, because I was also doing what other pilots would do. I would look at the sites that I was familiar with, and therefore I was neglecting the rest of the sites which I hadn't flown at or don't fly regularly at. And now when they started coming up on my radar, for example, on Saturday I flew from Noordhoek Peak, which is close to where Drew stays. And for a long time I didn't fly out that way because I thought it's a dangerous place and so on. And then when it started coming up on my radar as, this place is actually flyable, a decent amount of time, and I haven't flown there before, found out that it's not that dangerous, and now it's become one of my favorite flying sites. So it helps people discover, more different flying sites and so on, and just brings this brings it to your attention. I have called this tool sites worth investigating further, and it's because, again, I don't want you to make your decision on this is a yes to fly. No, it's a it's a yes that you should pay attention to it, because the first step, the surface winds, the overall weather looks good, and now you should go through step 2, 3, etc., to make your decision on whether you go flying there. And this is so what I have going at the moment. It's live on my website, and like I say, it's also goes out on my Telegram channel. My next version, instead of scoring it yes or no, I actually or giving a yes or no, I want to score it, and that will probably be like a 1B and a 2C and so on. That will be speaking to the wind speeds, and I'll fine tune that scoring mechanism, because I can think of the wind speeds, the direction, and as well as the temperature for thermals. But I haven't finalized that yet. But instead of a yes or no, I do want to have that output give me a little bit more, yet still in a table format, because it's easier to digest. I also want to have it send me an automated text with the best flying sites for example, for tomorrow. And the reason for this is, although Telegram has been useful for me, and the people in my school are all on it because I tell them to, there's a lot more people who are not on Telegram. They're much more comfortable using WhatsApp. And so if for me to just get a text message that I can send across to these various WhatsApp groups would be great. And I'll also use that text message, it'll be like a simple thing that says, oh, Lion's Head, Pal, and Solari's Pass look fantastic for tomorrow. Click on this link to analyze further, which will drive them to my website to drive web traffic, and I'm running a business. So that's one of the next goals on the next update. I'll also put in more efficient code, because Google Sheets does struggle, and every now and then it fails. We'll get a PDF with everything saying no because it failed. And then I'm going to do this for the whole country. I've already done the majority of the work in my script of scraping text. So I'll just fine tune that, because it does need a little bit of changing for the rest of the country. And then I'll be able to use this to forecast for the entire country, which should also help with website traffic. And then lastly, so currently on my website, when you go to it's running the Google script every time you open up the page or the page refreshes, which does take time. And it may take 5 to 10 seconds, but that's a bit of time for the user. So on the next update, I'll most likely be running an R script on a server in the cloud, and outputting a picture which would be a smaller file size, and therefore open up quicker on the website. This picture over here is flying over Groot Constantia out here in the southern suburbs. We really do live in a incredible part of the world, and I stumbled into airsports in 2004, so quite a while ago, and it's absolutely blown my mind. It's the reason I started my school, and it's one of the reasons why I'm talking to you guys, is because this is very much, a lot of the guys who are in this, you'll appreciate there's a lot of science to this. There's a lot of thinking, but it's still, we call it's like playing chess in the sky. It's playing a strategy game in the sky, and your wrong move should be landing. Every time I take off, the risk that I am fully prepared to take is that I land on the ground, and that's just part of the game. So whether I have a 5-minute flight, 50-minute flight, or a 5-hour flight, that is uncertain, and I try and use the things like weather forecasting to help me go to the right place to give me the flight that I'm looking for. But there's a lot of thinking to this, and I really believe that people understood this and realized that we've come a long way since the pioneering days, that the sport would really grow as it should. And when Howard and I started chatting just before the talk got going, The reason I started my school is because the data tells me that paragliding should be much bigger than it is in South Africa, and I'm testing out this theory because I love flying. Yeah, if you want to visit my website, airschool.co.za, I've made a quick, freely accessible, quick guide to explain various things with some explanations on the takeoffs and landings and how you learn the license process and so on. It's all for free. And if there's any questions, I would love to take them. Thank you.
Ria, thank you very much. It was really exciting, and it's amazing what one can do just with Google Sheets. I'm impressed with your tenacity. I mean, I suppose Google Sheets and Excel, it's amazing what we can do in one of the biggest database systems in the world.
For sure.
But thanks for that. Any questions? Are there any questions from any of the guys involved on the talk?
Hi, Ria. Thank you very much for the talk. I found it extremely exciting. My name is Kamal Kasim. I'm also in Cape Town. I never ever saw the sky the way you see it, right? I do see future potential here in terms of revenue generation. For example, aerial photography. There are companies out there that pays for aerial photography, and they're always looking for fresh pictures and all of this and that, right? That's one aspect of it. The other aspect of it is I can see your way of thinking is moving me towards what's happening on the ground and what can help me with a prediction of the next minute or to 5 minutes. Have you thought of integrating your flight suit with IoTs in terms of um, flight speed, direction, all of that type of stuff? And then maybe possibly integrated to something called Google Glasses so that you have that Iron Man experience.
That's a great question. I haven't thought about that, but you have definitely piqued my interest on that, and I'll give it some thought. I do know there's a company out in Europe. There's a Swiss guy I met earlier this year, and they are taking this like to the next level where they are. He's got a site that's very popular, a website that's very popular, and people go there for forecasting. But now they've also got them to be uploading their tracks live. So and he was telling me the other day, I think he's now got like 40,000 users a day or something now. So paragliding in Europe is huge. There's like 40,000 pilots in Germany, and we've got about 650 in South Africa, just to give you an idea of the size there. And so what they're doing is they are doing the live analysis, and you can see where people are in real time getting lift, going up in circles, using these bubbles to go up, which I can see it coming. There will be just at the moment they'll be able to display this live to other users in the area. So if you're flying in the Alps, there's a lot of pilots flying in the Alps on any given day, and so you'll be able to see where people are climbing in real time and use that in your decision making on the route that you choose or adapt your route. And of course, with that will come, the data science prediction models where you should be going and so on. And I can see that coming along in future flying, where we'll be flying with our instruments and it predicting and giving you, you should be going this way for your next thermal or for the optimal longest distance and so on. And just on that note, and this is where things are, it's such an amazing time to be alive. Our instruments, previously you needed a paragliding specific instrument, this, to do your flight. And pretty much today our phones are incredible. They have GPSs in them. They can be running the apps that we use for our navigation, and I'm sure that will also come with the predictive stuff in future.
Kamal, you comfortable with that? Any other questions on that?
No, I'm very happy I could pique his interest. So Rio, well done. Looking forward to the next release and the Google glasses, right?
Yeah, so I'm definitely going to look at that. Thanks, Kamal.
So, Ria, the one question that that Kamal brought up was the applicability to other possible air. What I mean, I was thinking about it, like aerial photography. And I'm assuming that's going to be handled by yourself. But I mean, at the moment, drones are handling that. So, how else could one apply this type of scenario? I'm assuming it may be hang gliding or things like that. What are the other options that we're looking at?
From an air sport perspective, yeah, you could look at hang gliding, sailplane pilots. What Kamal has brought about on drone usage, that's a good one because that's a growing market, and I haven't even thought about that. Um, you know, I'm sure they're doing their weather forecasting as to the detail levels that we're doing at, but maybe this would also be helpful for them to streamline and so on. Other, if we go away from paragliding, because this stuff, this kind of like tying in weather forecasts, you could tie it in with like just about anything. When I worked at Minute 24, could you tie it in with newspaper sales, or your productivity on whatever it is out there, whether it was in a factory or workers across the country, using the predictive weather data in the corporate and industrial environment, I'm sure will become more and more mainstream, which is why that data source that I'm using has come about, is to provide data for these kind of challenges.
Okay.
I do know that they're also using this prediction tools when there are mountain fires.
Oh yeah.
Yeah. So then they can actually predict where to send the drones in, detect hotspots and all of that type of stuff. I've got a background in a services industry, municipal services industry. And one of the things that they've done is that I don't know if you know the gun stop spotter that's used by the city of Cape Town, or it was used. So effectively what happens there is they've got the CCTV cameras all over the show.
Yeah.
If a gunshot is detected, they freeze all CCTV cameras and the recordings, right? Put it to a different space. And then they rewind it 5 minutes so that they can recreate the gunshot, where it took place, who took it, all of that type of stuff. So in the same light, could one apply that to, let's say, the hikers or the mountain trailers or the mountain bikers and all of that type of stuff? Because where you're flying is over nature areas, and surely you have visibility of that.
Practically, I think like from our visibility as paragliding pilots is somewhat limited in the practical use. Like for example, on Table Mountain, we've got a hiker that's gone missing. Just the number of paragliding pilots who are flying out of here is currently so small, then that's a limiting factor on its own. And then because we will be using, we need to fly a line that we find the bubbles, so not necessarily conducive to identifying people. That's where drones will definitely, drones will fill that gap in a much more effective way. So I think that the currently using paraglider pilots and even anything that we're carrying to assist would be quite a limiting factor. Maybe if paragliding became as big as my dreams are, then then there'll be value in it. But currently, there's definitely that will be the setback.
So, Rio, we got another question here from Marvin. He's saying, Very interesting, thank you. How do you manage the metadata for the forecast predictions, especially with changes to climate?
So we're saying that so the forecast prediction that we're doing is for a particular site.
Yeah.
And that's, if that, it doesn't, even if that site over time, now let's say, is experiencing higher winds or temperatures or whatever it is because of climate change, that still doesn't affect the decision on whether you should go flying, or whether this tool is giving you a yes or a no, because that's pretty much the decision making is the wind speed, direction, overall weather, and so on within the flying parameters, and if so, then it's a yes. And so things like climate change, it could affect the flyability of a site over the long term. But then all that we would see in terms of the results over here is that, let's say it was for Lion's Head, that starts, things start changing, or Signal Hill, or whatever it is, that over time that site would be forecasted and quite likely practically flown less if it were to become detrimental. But it will have the things like climate change will have no effect on the actual logic that is used to decide whether it's a yes or no.
No. Martin, does that answer your question?
Yes, it does. Yes. Yeah. Thanks. Yes. Yeah.
Okay, great. Thank you. Drew, final question from you, sir. So you snuck in there now that I got to get you before you go.
Yeah, I think the last question about the metadata and Ria's answers, because we also focus so closely on kind of micrometeorology and in a very confined space. However, that does get aligned with kind of last time the wind blew this speed, this direction, this, we saw a result. So it's about building up knowledge that you combine then with fact, and hopefully align that with some metadata as well, which is contained in those different data models, the weather models.
Yeah. So it's almost like what Ria had in his master data that we spoke about with the general wind recommendation south-southwest for Regalis. That may change over time, and that may need updating, especially if you go all over the country and you're not really there and you don't always have that feedback. But I'm assuming that because I'm not sure what the body is that manages these sites. You mentioned that someone managed the sites. Do they give you any input on what that general recommendation is?
No, I was talking about the CAA, the Civil Aviation Association.
Yeah.
But to answer what you brought up now, Howard, that's not the case, because our takeoff site direction would be influenced by the geography, meaning the slope direction.
Right.
And that's not going to change for thousands and hundreds, a long time, unless it was man-made change that changes it.
Yeah.
So that addresses it. But I just want to mention something. So before I built this, and actually a few years back when I was still practicing as a data scientist, and I was, got really involved in my paragliding and long distance flying. And then I tried to do things of, trying to predict the really good days and go in depth in the 2D analysis and temperature profiles and so on. And to do this exercise, what I did was I first started off by asking other pilots to give me the days on which they had great flights and the days on which they didn't have great flights. It was horrible. You don't want to be in the sky. And before I could go, properly in depth, I took the flights, the days on which they had these great flights, and put them up graphically so I could see those temperature profiles, and have a quick visual analysis of it. And what very quickly became apparent is that you can have great flights on the great looking days when your thermals are going to go up to 3,000 meters and there's going to be lots of them. But then you can also have great flights on the not so great looking days when your thermals only go up to, let's say, 1,000 meters, which in our world is not very, very high. And that was a big learning point for me. And I've since experienced this myself, where I've had epic flying that's got me, like last week, this past Saturday when I flew over Drew's house in Noordhoek. I spent about 40 minutes in the sky, away from the mountain, over the suburb of Noordhoek, trying to get closer to the clouds, dropping out, and so on. And therefore, I was like, you can have great flying on the great days. You can have great flying on the crap days. You just shouldn't go flying when it's dangerous. That's where I draw the line.
Yeah. Okay. Drew, did that?
That's where the knowledge side comes in. So we knew that there was this big cold front coming through, that there's going to be some nasty weather, and over time, guys have learned a day, 2 days before that just don't go out. And yeah, the rain hit us today from 12 o'clock. And yesterday on the ground, the wind was 0. One of the guys posted he was up the hill at Muizenberg and it was gusting 50, 60 k's an hour, just 300 meters up the hill. So it's very, very micro.
Fantastic. Ria, so I appreciate the feedback. I really appreciate the practical experience and understanding how I just feel that probably the data that you've brought to the community has been phenomenal, just in terms of the insights that they get compared to, as you've said, the sites that you start flying that you never thought about, that must open up a lot of opportunities and get people to see a lot wider than they are. I think it must be a great value. Drew, could you comment on that, or are people talking about it?
Constantly, Howard.
So it's decision making, right? So it's data management is all about making good decisions.
Absolutely. The better the data that you got, the easier the decision is. So, I mean, so I'll put it in perspective. One of the sites that is a really, really good site is up at Portable, but it's 180 Ks. So you don't want to drive all the way there and get there and find that you can't fly.
Yeah.
So Ria and his cronies through their work have opened up sites that are much more local that work as well. And in fact, I flew with Ria one day almost to Portable on a day that wasn't supposed to be that good. So yes, definitely it's about the data, but it's also about sharing knowledge, teaching others, which is where Ria is so good, teaching others how to also process the data. It's about like the train the trainer, share the learning.
Great. Guys, any more questions? I think that's been fantastic. If that's done, Ria, I really appreciate it. We'd love to get some feedback on your next version, or if we can help build it, be part of it, that would be fantastic. Anybody else have any comments, suggestions? Great. Thanks, Ria. Appreciate the time. Thanks, everybody. Have a wonderful night, and appreciate the input.
Yeah, and from my side, Ria, thanks as well. I know I baited you into doing this, and I feel guilty that I wasn't able to stay and watch, so you'll have to do it again.
Yeah. Drew, good.
Only a pleasure. Thanks, guys. Thanks for having me. It's been
Thank you very much.
Thanks all.
Cool.
Thanks, Howard.
Okay, bye.
Thanks, man.
Thanks, guys. Cheers.